Today, we're doing a deep dive into an area of security that often gets forgotten in the whole conversation about firewalls and encryption.
Physical infrastructure.
Exactly. We're peeling back the walls to look at the actual copper wiring connecting sensitive networks.
hmm
So if you're managing data in a highly secure environment, I mean, the big question is, how do these places, especially military installations, make sure their RF signals can't be intercepted?
Or worse, manipulated.
Right, through the building's own infrastructure.
And to answer that, we really have to look at a specific piece of hardware. It's called the Thor Broadcast, FRFBR RF fiber break.
Okay.
The official description is an optical RF coax isolation solution.
That's a mouthful.
It is. But our mission today is to unpack how this little box solves a huge security flaw, a flaw that's just, built into almost every traditional coaxial cable setup.
Okay, let's unpack that then. Standard coax is everywhere. I mean, offices, homes, secure facilities. Why is it suddenly a serious security threat for sensitive data?
Well, that's the thing. It seems harmless, but standard coaxials inherently allow signals to travel in both directions.
And that's a problem because
Because in a high-security environment, you need absolute control over data flow. That bidirectional capability is a massive risk. It's not just about someone listening in.
it's about them talking back.
Exactly. The real threat is an attacker injecting a malicious signal, maybe corrupted data, right back into your supposedly secure network through that same physical cable.
So the goal is to create a forced one-way street for the data. This device is, what, like an optical air gap?
That's a perfect way to put it. It's a high-tech data check valve. It's engineered to transmit RF signals over a single directional fiber link.
A single direction.
And this is the crucial part. The system is designed without any return path optics. The signal physically cannot travel back. That is the non-negotiable security guardrail.
Okay, let's pivot from the why to the what. We know it uses fiber, but the source materials call this a low-cost solution for short distances. Now, wait a minute. If security is absolute, where's the engineering compromise to get that price point?
That's a great question, and it seems like there isn't one, not on the core integrity anyway.
So how is it low cost?
The cost effectiveness comes from its very specific focus. It's got a compact form factor, it's controlled by a microprocessor for reliability, and it handles a standard work bandwidth.
The CATV band, right? 45 to 862 megahertz.
That's the one, though you can get options for satellite bands too. It does one job, and it does it really, really well.
So the proof is in the technical specs then. Because when you're moving sensitive data, the last thing you want is the cable itself polluting the signal.
Absolutely. And the performance metrics are where the security value really shines. These numbers show just how resilient the signal is.
Give me an example.
Okay, take the carrier-to-noise ratio, or CNR. It's guaranteed to be greater than 50 dB.
And that's good.
That's excellent, especially because it holds true even across 10 kilometers of optical fiber. That isn't just a quality number, it's a security feature. The signal is so strong and clean that tapping it becomes exponentially harder.
And what about those other acronyms, the distortion numbers, CTD and CSO?
Right, the alphabet soup. Those numbers, composite triple B and composite second order, are all about signal purity.
So less ghosting or interference from the device itself.
Precisely. With numbers like CTB under negative 63 dB and CSO under negative 57 dB, it means the output is extraordinarily pure. You're getting maximum data integrity. And the engineering margins are so robust they stand up over huge distances, even if you're only using it for 100 meters.
So what's the big takeaway for you? It seems to be that real digital security sometimes means ripping out common bidirectional hardware and replacing it with something physically designed to be a one-way street.
Yes. Security by architecture, not just by encryption.
It's just as critical.
It is. This device really underscores that even simple things like the physical path your data takes are vital control points that have to be managed.
Which really raises a final thought, doesn't it?
It does. If a basic, everyday coax cable poses a risk to sensitive military data, what other everyday, unisolated communication channels might be creating unintended vulnerabilities?
For big organizations, or even for us.
Exactly. For us in our own smart homes and offices, something to think about as you look at your own security footprint.